computer. Okay, so hello. Again, name is Boris Jeremic. We're going through demos of really easy running problems. Post-processing, we're going to do post-processing now. We're going to post-process that one frame that we've seen before. With me are Dr. Han Yang. Say hi.
Oh,
and,
hi.
And
Hi.
Mr. Heshen Wang. Heshen, say something.
Hey,
so
hi.
You get the focus. We're going to go to Heshen's screen. Heshen, can you share your screen?
Yeah.
And then go to, good. So we're in this directory. Show us ls minus flag t. We're in this directory where the results of the previous run were located or were saved, and we're now going to run ParaView on these three files. The three stages of loading. First one is just a check model. Then we're going to look at the results from pushover. Then we're going to look at some select results from free variation. So go ahead, run ParaView.
Should I open the
you
check
can run
model?
ParaView directly like this, or you can open. So maybe just run it on that first check stage.
Okay.
Or yeah, do it this way. Actually, that's good. I mean, whichever way you want. I mean, I don't mind whichever way you prefer.
Okay. So if I do ParaView on the file name, it will open the file.
Yeah.
And then you need to click this apply button to apply the model.
Okay.
And then you might want to change the coordinate system. Yeah.
Make sure the coordinate system is done right. Okay. So this is now we're in XZ plane.
Yeah.
This is our frame, but it's kind of thin line. Can you make that line thick?
Yeah. Then you go down there, the option called the line width. You can change this to a bigger number. Let's say 10. It will become thicker.
Good. So we can see the model now. Perfect. One thing to check is, well, can you number nodes and elements just to see how? I mean, this is possible. This is useful for smaller models like this. When you have a huge model, it doesn't really.
So as you can see here, when you click here, you can select all the elements in the model, and then when you go here, style labels.
Go slowly.
You click the element tag. It will show the tag of all the elements in the model.
Okay.
And if you want to see the nodal tag, you can go to the point labels.
Okay.
Click this and check node tag. It will show all the node ID.
In different colors, you can see nodes and elements. Okay, good. Remove those and let's look at the form shape. Oh no! First of all, let's look at the boundary conditions.
Okay.
So just to make sure.
Yeah. Here you can choose a bunch of options which you want to see. You can choose boundary conditions to visualize, and here you can see.
So
because
remember,
we are go ahead.
Boundary conditions. Now what are we showing here? Boundary conditions. We are showing all three or all six of them, or what?
Yeah, I think here it's all six of them. Yeah. So you can see when we fix a 6 degree of freedom, then for example, this node is going to show number 6. This also is showing number 6. But for other node, it's just a free, which means we didn't add any boundary condition, which will show 0. Yeah.
But wait, but it doesn't show 6. It only shows.
I think this is
no, it doesn't show 6. It will show the square root of 3, I think.
Ah, okay, yeah, 170. Okay, 173.
Oh, square root of 3.
So
okay.
it's essentially going to be a norm, a second norm of boundary condition. In this case, it's kind of stupid thing because boundaries are really one fixities.
Right, but you can also see the boundary condition in each direction by changing the menu on top of there. Instead of magnitude, you see UX, UY, or UZ, or whichever one you want to see.
Oh yeah, this is the magnitude.
Okay.
Yeah.
Okay.
So let's say if you want to visualize UX, yeah, it will show.
Yeah. So these are boundary conditions in x directions. Yes. Good.
Yeah.
Excellent. Okay. Let's show the form shape at the end of pushover.
Okay. So now we can open the second output file. Say we want to look at the pushover file. Then we can again apply this model. And then, for example, we do not want to see the first stage. We can click this icon here. Then it will be hidden. And then again, we want to make the model much thicker. We change the the line width. To be much larger value, that becomes thicker. And then we can use this wrap by vector to show the deformed shape of the structure. So we add this wrapper, and then we click apply again. And then here you need to see what quantity this wrapper going to apply on.
So what you're showing now is boundary conditions. We actually want to show displacement, yes.
Yeah, we want to show the displacement. And then here you can choose a scale factor of this wrap. Let's say 50. Then you again apply. And you want to make the model much thicker. Okay. And then you want to show
what you're showing right now is the up there, it says time step 0.
Yeah, time step 0, yeah.
So this is at the very beginning, but we actually want to go to time step 10 at the end of the
loading, we can go to the end of time step. Yeah. So now you can see the deformation. And again, you can also add the displacement field over this over this deformed shape. Yeah.
Good. Yeah. Okay, so this actually moved sideways. What's that number? 8.2 times 10 to minus. So this is 8.2 centimeters moved to the right?
Yeah, that's true.
Good. So, and can you show maybe one more thing? Can you just show, what else can you show? Can you show maybe energy, strain energy, or maybe energy dissipation? Because this model did the yield. Yeah.
So you click back this main file, and then here we have a bunch of options. You need to check the number 1, enable Gauss to node interpolation and enable energy visualization. So once you click this two, just again apply. And then here you have a bunch of options you can visualize. For example, you can visualize the plastic dissipation of the plastic dissipation density of the model.
Okay.
So we click this, and then
apply.
No, here you should also. Okay, so then you can visualize the
So as you can see, because there's a push up there. There's a lot of dissipation down where the major moments are. However, on the right side. On the right side, there's more dissipation because that component, that side has an even larger normal force. So there's dissipation from normal force and from bending. Left side has pretty much only bending. A little bit of tensile force. So the right side gets much more damage in the concrete, and left side gets some damage in steel, but it's much less than this. Okay, good. Well, thank you very much. Let's go back to third stage of loading. So first one was check model. Second one was pushover. And the third one was the free vibration. Let's see how that system vibrates when you remove that load. Yeah, so free vibration.
So now we are open this free vibration output. And again, we apply the model, and then we go to, so we change the coordinate system, and then we add the wrapper.
So we go up 50 times again, okay?
Yeah, and then we make it thicker.
Yeah, make it thicker, although you can see it here, but make it thicker, make it thick, 10 thick or something like that.
Yeah.
Okay.
And you can visualize the displacement field of this beam. And initially is deformed from the pushover, and then when we click this play button, it will show the dynamic vibrating of each load step.
So hold on. So this is how come it's not? Wait. Go back to first step. Go back to step 0. Step 0.
Okay. I think the coordinate system.
Change the coordinate system. Yeah, go back to
that's right. Yeah.
So this is at the end of the previous stage, and what you do now, you release in the third and then you let it go. So now it's going to start to oscillate. Okay, let's do that.
Yeah.
So it oscillates and it slowly slows down because there's damping, there's material damage, and the system slowly slows down. Remember, this is for 5 seconds. Actually, no, it's for 50 seconds. 500 steps at 0.
5 seconds, 0.01 seconds per time.
Oh, that's right. These are step numbers. The 500 steps down there. Yes.
Yeah.
So, excellent. Good. Well, thank you very much. So, so I think we'll stop here. you're more than welcome to download these examples and play yourself, and then we'll record some more demos. Thank you very much. So Hesham, can you stop? Can you stop sharing screen?
Yeah, sure.
And then I will stop recording, and then we'll go to next example. That's going to be Han Yang's example with solids and shells and whatnot. Thank you. See you later.